Hey, what's up? Uh, see, I'm back here with another very important topic, and this is about preparation of carboxylic acid from the nitriles, right? And also from amides. So it basically belongs to same equation, but I'll be explaining you both of these parts. So let me repeat back again. I'm talking about preparation of carboxylic acid from nitriles and also from amides, right? So I'm not going into the something else. So let's start the topic and go through the mechanism and everything possible about, right? So like I said, we have our very first topic, it's also a conversion, and what that is called nitriles to carboxylic acid. Nitriles to carboxylic acid. So you can consider this as a conversion, but you can also consider this as a preparation of carboxylic acid. So let's see how this happens to be. Let's take an example, a very common example, that there you have a, nitrile. What this is called? This is called nitrile. You also call it alkyl cyanide. So what happens? This nitrile undergo reaction in presence of water. And what you do know that a water has two hydrogen and an oxygen, right? So what happened? You need to understand that this carbon is basically a Lewis acid center. Why? Because it's bonded to the nitrogen. So what happened? Nitrogen react with both of the hydrogen. I'm taking you through the short part first. So nitrogen react with both of the hydrogen while the carbon react with one of the oxygen. So what happened? This forms RC double bond O, and then this become NH2. So what this is called? This is called amide. Right? So right now I'm taking the short part. Then I will come to the mechanism. So this has become amide. Now in the next step what happened? This further react with water, or you can say hydrolysis happen. You can also write it like H2O, because there is no difference between H2 and H3O, because water produces hydrogen ion and that hydrogen ion react with the water to form hydronium ion, right? So there is nothing wrong writing even the H3O positive here. So what happened when this one react? You have to understand that a water has two basically ions. One has proton and other has a hydroxide ion, right? Let's concentrate here. What happened? This nitrogen has an oxidation number of -3 and hydrogen both of them have a +2. Now what you can see that the hydroxide is also having a -1. So the net difference is -1. So what happened? This hydroxide displaces this entire NH2 and this become your carboxylic acid. So this become carboxylic acid. Right? I hope you understood. It was the shortest way to make you go through. Let me repeat back. Because carbon here is a Lewis acid, so what happened? This require a basic part here, and there oxygen is the basic part here. So oxygen react with the carbon and nitrogen react with both of the hydrogen, and this way it forms a amide. This way it forms a amide here, and this is what amide is. Now what happened after the amide is formed? It further react with the water, and then the amide converts into carboxylic acid. Right? How this reaction take place? On the basis of oxidation number I'm explaining, that what happened here, that nitrogen is having a -3 and this hydrogen is having a +2. So what happened? The net difference is coming out to be -1. So this -1 overall is replaced by another -1, which is nothing but hydroxyl group. So that's why it forms a carboxylic group here. This is my way. This is simply a different method to make you go through. Now let's take another example and go through that. Suppose I'm taking methyl cyanide. So CH3CN. I could have taken anyone. CH3CN. So this is your methyl cyanide. Now what happened? Methyl cyanide react with water. Right? And when it react with water, simply the same thing will happen. What will happen? This will form CH3, right? CH3C double bond O, and then there will be NH2. Don't mess up with this one, right? Because this is something from the upper reaction here. Okay, so this forms a amide here again. So methyl cyanide become, acetamide. What this is called? Let me write this. This is called, acetamide. Okay, now in the next step, what happened? Again, this react with the water. So when this react with water, what happened? This again will be converted into a hydroxide group. So this is how carboxylic acid is produced. Let me see if it's coming over there or not. Yeah, so this is the shortest way you can, this is probably the shortest way you can make the reaction go. Let me repeat back. A cyanide converts into amide, and amide hydrolysis, it undergoes hydrolysis to produce a carboxylic acid, right? Let's take you another example there, taking the, nitrile of different type. Suppose I am talking about this, kind of nitrile. This kind of nitrile, right? So this is also nitrile. Now what happened? Again, what you need to do? You need to react it with water. So when you react it with water, what happened? This oxygen, this benzene has nothing to do, but this carbon attach itself with the oxygen, and this nitrogen attached with two of the hydrogen, right? So this forms your, benzamide here. So this is your benzamide. What happened in the next step? Again, this further react with water, and if it's react with water, what will happen? Similarly, you will get your product, and what that product is going to be? That's going to be C double bond O and then OH. So this is your benzoic acid. Benzoic acid. So these reactions are not only about the preparation of carboxylic acid, they are also representing to the conversion from this to this, like from nitriles to carboxylic acid, from methyl cyanide to ethanoic acid, and finally here you have phenyl cyanide, or you can call it nitrile also. That nitrile converts into benzoic acid. So these are the common reaction I made you go. Now the question has come, how this reaction takes place and what is the mechanism. That's very important. That's going to be, so just pay attention and try to get it through in depth actually. One very important thing that I missed here is is that what happened to this NH2 here. So that's very important. I tell you exactly what happened in all these three cases. In all these three cases, ammonia is released in the form of gas. So what I'm doing here, I'm writing here, because I have lack of space over there. In all three cases, NH3 gas is released as a byproduct. So that's what happened with the remaining part apart from the main compound here, right? So now let's talk about the mechanism. Okay, so we have to do the mechanism part now, and that's going to be really interesting. Let's see what this is. What we have here is this nitrile, and another thing we have is water. So water, definitely is a source of proton. Water is a source of proton here. Water is a source of proton. Now you probably do know that nitrogen has a lone pair. So what happened? This proton undergo reaction with the nitrogen because it is nucleophilic by nature, and hydrogen is attracted simply to the nitrogen. So this forms C. You have triple bond N. You have triple bond N and a positive charge now, and you have one hydrogen here, right? So this is what it looks like. Now, because nitrogen is unstable, because it has a positive charge, so in order to stabilize itself, what happened? This nitrogen react with water molecule. This nitrogen react with the water molecule. So what you have here is a water molecule. Now, as you can see that because this one wants to stabilize itself. So what happened? This bond undergo cleavage. So this one undergo cleavage, but in that case, carbon attach itself with the help of this carbon, this oxygen here. So what happened? You get R, C, and you have two bond here. Now then you have nitrogen. You have a nitrogen, and with the nitrogen you have a hydrogen. Now no positive charge is there, but this carbon is attached to the oxygen here. Carbon is attached to the oxygen, but oxygen has a positive charge now. How this has a positive charge? Because this has donated one pair of the electron. So this is a product coming out. Now what happened in the next step here? You have to pay attention right here. Oxygen is now quite unstable because of having a positive charge here. So what happened? It has only option to break one of the hydrogen bond, one of the bond present between oxygen and hydrogen. So suppose this bond is breaking. This bond is breaking here. So what will happen? This hydrogen will come as a proton here. So you have your proton here, and then apart from that, another thing is that, let me write this product here. So you have R, C, and you have a double bond, you have N, and you have H, right? And along with carbon, you have a OH here now, right? But you have to understand that the nitrogen is still having a lone pair. So what happened? Due to this lone pair, this hydrogen is attracted towards the nitrogen, right? So this nitrogen goes with, the hydrogen go with the nitrogen, right? So what happened? This is what coming out to be R, C, you got double bond, N, and you have now H2, but it has a positive charge because it has, given its electron to the proton, right? Now, another thing is there which I am missing here, it's OH here. Now there is another problem creating. What is happening now? Nitrogen is unstable. Now the nitrogen is unstable. So the only option nitrogen is having to get this bond cleavage. So when this bond undergo cleavage, this become definitely neutral species. But at the same time, this become a NH2. But the problem is that this carbon becomes a positive charge. This carbon becomes a positive charge here. So what happened then? This bond undergo cleavage. But after this bond undergo cleavage, this is what happened then. You have your R, you have C, and then you have a single bond. You have then NH2, right? And you have a OH here. You have a OH here. Let me expand this. So you have a OH here, but this carbon is having a positive charge. Now the question is that now this carbon needs to be stabilized. So in order to do so, this bond undergo cleavage now. This bond undergo cleavage now, and what happened exactly? The electron released, transfer to here. So what you get now? You get R, you have C with the positive, with a double bond here, oxygen, and you have NH2. You have NH2. Now the lone pair is still there, but along with that you have a proton. You have a proton, right? Now again this proton attract towards the NH2. This proton attract towards the NH2, and due to that, what happened? It forms R, C, single bond, NH2, and NH3 in fact, sorry. So this become NH3. Okay, and you have a double bond with oxygen right here. I hope each of the steps are going in a very natural way and you are understanding every part here. Now let's concentrate back here. Now the nitrogen is having a positive charge. Nitrogen is having a positive charge because it has given its own electron to the hydrogen. In that case, what happened? There are plenty of water there. After that, what happened? This intermediate react with water. This intermediate react with water because in the system there are water. So what happened? This bond undergo cleavage. So as a result, what happened? You have ammonia out there. So ammonia is released out of the system in the form of a gas. So this is forming a gaseous ammonia and going into the atmosphere. Now, after the bond has undergone cleavage, what will happen? The carbon will become electron deficient. In order to fulfill its electron, what happened? This pair of electron, just a second, this pair of electron attach itself to the carbon. And after this, now what happened? You have R, you have C, you have a double bond there, and you have you have water. You have water here. Water, but oxygen will have a positive charge now. So this is what the situation looks like. But apart from that, ammonia was also there, right? So this looks like, so you had ammonia, You had ammonia, but along with that, this byproduct was also there. What happened in the last step then? This bond undergo cleavage. So if this bond undergo cleavage, what will happen? A proton will be released. A proton will be released. This proton will be released. Now this becomes your carboxylic acid. So R, C, double bond O, and you have now OH. So though I'm not happy because I wanted to show everything right here, but you need to go on your own and see how this mechanism, though it was a bit lengthier, but it was also very interesting, I believe. So what I have now, we have now carboxylic acid. The reaction started from the nitrile, but it went through several different protonation and deprotonation phases and finally came out as a carboxylic acid. So this is what the mechanism of nitrile to carboxylic acid is. I hope you have understood everything. Let me repeat back what happened. The nitrile react with water and it formed first amide, and then the amide undergo hydrolysis to produce carboxylic acid. So thanks for watching and see you again.